Kia ora, here's a question from Scholarship 1965. So you need to grab a pen and paper and have a go at this before I go through it. So we need to differentiate this function here. And it looks worse than it is. We're going to use the log rules to simplify it pretty heavily before we start doing any differentiation. So just going quite slowly through that, we're going to have y is equal to the log of this to the power of 1/2. So that equals 1/2 times the log of this. And now we're going to use the rule for the log of a quotient to get this. Y is equal to 1/2 log of 1 plus sine x minus 1/2 log of 1 minus sine x. Okay, so now we're ready to differentiate. I'll just write the function out again here. And dy by dx is going to equal the derivative of a log, remember, is 1 over the function. And now we need to apply the chain rule and differentiate the inside function. So the derivative of 1 plus sine x is just cos of x. Okay, similar process for the next part. It's going to be minus, in the denominator, 2 times 1 minus sine x times the derivative of the inside function, which is negative cos of x. And you can already see in the denominator that you're going to have some simplification that can happen there. So now, getting a common denominator of 2 times 1 plus sine x, 1 minus sine x. The first term becomes cos x times 1 minus sine x, plus coming from here, plus cos of x times 1 plus sine x. So that's going to simplify to give me 2 times 1 minus sine squared x in the denominator. And in the numerator, I've got cos of x minus cos x sine x plus cos of x plus cos x sine x. So that equals 2 cos x over 2 times 1 minus sine squared x. Okay, so we're down to here, 2 cos x over 2 times 1 minus sine squared x. Right, using the Pythagoras identity, we've got 2 cos x over 2, well actually I really by now should have got rid of the 2's. Cos x over cos squared of x, which is equal to 1 over cos x, which finally simplifies to sec x. Okay, so a pretty nice, easy differentiation question. As you know, these days you don't usually get the questions that are that pointed, but it's still quite good practice in how we can use the log rules to really simplify heavily before we start differentiating.